Right, the grade 10s, let us look at your question 2. Right, in your question 2, let me just draw up a line. In your question 2, we have the following. So these are going to be separate tutorials. In question 2, we have solve for x, and in 2.1.1, this is what is given to us. They say 2x squared minus 10x is equals to 0. Now the first thing that we need to do there is to see that I can divide everything by 2 because it leaves no remainder in every number that is here. So that's the first thing that you will do. 2 into 2 goes once. You are left with your x squared. How many 2's? Write your subtraction. How many 2's can you pull out of 10? 5x, don't forget. 0 divided by 2, 0. We have spoken about this many times. There's a common factor here of x. You took out 1x, 1x is left. Write your subtraction. You took out x in here, you are left with 5. So x equals 0, or x minus 5 is equals to 0. Something very important that you need to know here. So take to the side x equals 5. So you have two values of x, 0 and 5. Right, that was 2 marks. 2.1.2 px minus kx equals k minus p. Now remember, they said solve for x. So what I can do in here, there's something common here, which is x. I took out x, I'm left with p, minus I took out x, I'm left with k, which is equals to k minus p. Now look what is happening here. I can divide by p minus k, p minus k. Listen to this, goes once. You are left with your x, and now look what is happening. You have k minus p as the numerator. In here you can factor out a negative. If you factor out a negative, remember p is positive, so if you factor out a negative, it will have to be negative, so that negative times negative is positive. Your k is negative, so this has to be positive, so that positive times negative, it's that negative. Now let's just try to rewrite this nicely. So your x equals k minus p minus, so I have my k minus p. You see, so this and this goes once. Your x is negative 1, because you will have negative 1 over 1, which is negative 1. Something worthy of noting. Alright, that is fine. Let's go to 2.1.3. 2x divided by 3 equals 1 over 128. So in here you need to write 128 with a base of 2. So you have your 2x divided by 3, 1 over 2. I think it's 2 to the exponent of 7. Let me just verify it very quickly. 2 to the exponent of 7. 2 to the exponent of 7, 128. Yes, so this is 2 to the exponent of 7. And what does the law say? 2x divided by 3. If I want to take this to the top, you write the base, and because this is going to the top, the exponent becomes negative. That is the law of exponents. That is how you bring this to the top, and that one disappears. So if the bases are the same, you equate the exponents. You just say the base disappears, and you just have x divided by 3 equals minus 7. You want to get rid of the denominator, you multiply both sides by 3. This into this goes once. Your x is minus 21. And that becomes the value of x. So that becomes the answer for the problem. Right. So let us continue in this. So let's go to 2.2. Right, in 2.2 we are given that x plus 5 divided by 2 is bigger than minus 2. Now remember, they say solve for x, and I might do things a little bit different in here, so please try and follow very carefully. I'm going to take this to the side. It becomes positive, bigger than 0. And then from here I'm going to take out the lowest common denominator, which is we can use even the grade 5 method. I want to make the denominator to be 2, so I'm going to multiply this by 2 over 2. So that is to say, I'm going to leave 5 plus x over 2, and this 2 over 1 I'm going to multiply by 2 over 2, and I will have x plus 5 over 2 plus 2 times 2, it's 4, 2 times 1, it's 2. Now the denominators are the same, bigger than 0. And then from there, you just write your denominator of 2. And then you just say x plus 5 plus 4. You just say x plus 5 plus 4. And then you will get x plus 9 over 2, that is bigger than 0. Now when you are in here, what is it that we can do? We can calculate the critical values where we equate this to 0. You just say x plus 9 over 2 is equals to 0, because you have 0 on that side. Immediately when you have 0 on the right, you calculate the critical values by saying this is equals to 0, and then you can multiply both sides by 2 because you want to get rid of the denominator. X plus 9 is equals to 0, your x equals minus 9. Alright, and then you go to your number line, minus 9, there it is. So what is it that we are saying here? On this side we have negative infinities to minus 9. It is not inclusive because it says greater and not greater or equal. I will assume you understand the inequalities. And then in here we are moving to the right. Negative 9 is to infinity. And then from there we need to draw up the table. Right, if we draw up the table, this is what we will get. You have your negative infinity, you place this minus 9 is to infinity, very good. And then on this side you place your equation. Now remember your equation, there it is x plus 9. That is your equation, right, which is equals to 0. So take a value that is less than minus 9, that will be minus 10. Take a value that is greater than minus 9, that will be minus 8. And then you plug it in here. Minus 10 plus 9 is negative. Minus 8 plus 9 is positive. Okay. And then what else do we have there? Now remember what they said. They said that this needs to be was this the equation? Are we taking this or are we taking that? No, let's take this. So in here, if we substitute, we will have minus 10 plus 9 divided by 2, it's still negative, and this is still positive. Now remember, we are looking for the solution where this is positive. So where did we get a positive? Here. So your solution would be negative 9 is to infinity. Now let's check if this is true. Now remember what we have. We have x plus 5 divided by 2 plus 2 bigger than 0. We have to find, when we substitute x here, this has to be positive because numbers that are bigger than 0 are positive. So let's look into this. Now we are saying minus 9 is not part of the solution because we have an open bracket there, not a squared one. So let's take values that are to the right of minus 9, which is minus 8. Let's check. Minus 8 plus 5, that will give you minus 3 over 2 plus 2. Is this going to give you a positive answer? Yes, this is positive, this is correct. So every value going that side will be correct, so this is fine. Another way somebody might say when a problem, so let's look at method 2. If you have x plus 5 over 2 bigger than minus 2, somebody might want to get rid of the denominator by multiplying both sides by 2. X plus 5 bigger than minus 4, take to that side or bring to the side. X is greater than minus 4 minus 5, x should be greater than minus 9. So values that are greater than minus 9 are the solution, and which is very true. We saw with minus 8, but this sometimes it is very useful because it will give you in an infinite number of solutions. You will see when we get to grade 11 and grade 12 the danger of using this method, but for now it works just fine, no problem. You can apply it maybe in grade 10 to some problems, but not all. Right, let's go to that was 2.2.1. they said solve for x, and in 2.2.2 they say if x is a real number, represent the solution on a number line. That's exactly what we do. We have minus 9. You make an open circle because it is greater, and then you point the solution on a number line. We are accepting any values that are bigger than minus 9 going to infinity. And then that would bring us to the end of our tutorial for today.